Hello everyone, welcome to VisualFOAM tutorial number 3. In this tutorial, we are going to set up the win around building case, which is taken from the official OpenFOAM tutorial. By using VisualFOAM, we can set this type of case very easily in just minutes. So let's get started. First, head over to visualfoam.com and then click Start Foaming. Then we enter the case name. Here I type win around buildings. Select the open foam version, and the latest one is the V2512. Start foaming. First, we upload the OBJ file like this, and then we add the refinement box. Go to searchable objects, add searchable objects. Type refinement box 000 250 180 and 90. Save property. Now we have the refinement box, and then go to the mesh menu, block mesh. Here we set the minimum and maximum dimensions of the block mesh, -20, -50, 0, 330, 230, and then 140. And for the number of cells in each direction, it is 25, 20, and 10. For the boundary, the X minus here, we should set it as inlet with the type of patch. X plus is outlet. Y minus, the side one is front and back. Y plus is also front and back. Z plus, the top boundary, is also front and back. And then for the front and back boundary, we set the type to be symmetry, and then all automatically uh, boundaries with the same name will be changed to symmetry. And for the Z minus, for the bottom one, we can call it ground, and the type is wall. Now go to the Snappy Hex Mesh menu. In the general menu, we disable the add layers, and then go to the geometry. Here in the buildings, we add the refinement surface with a level of 3 and 3 for both minimum and maximum, and for the refinement edge, we set it to 1. And now we set the refinement box. Go to searchable objects, refinement box, and in this time we set the refinement region level 2. And then castellated mesh. Here we set the location in mesh. Here 1, 1, and 1. As long as the point does not coincide with the solid buildings here, it's fine. And then for the snap, we can skip it. Also for this step, and yep, we are done with the meshing process. Should be very easy. And then for the next step is the physics. We can minimize the mesh menu. For the solver, the default is simple form, steady, incompressible, and turbulence. And the selected solver is simple form. And when we select the solver, the menu appears on the left side. And now we set the transport properties to be Newtonian, the kinematic viscosity, leave the default value. For the turbulence properties, we set it to K epsilon. For the initial condition, for the pressure, velocity, and nu t, we leave them as default 0. And for the K, turbulent kinetic energy is 1.5, and for the epsilon is 0.03. This is according to the values described in the default tutorial of this case. And for now, we go to boundary condition. First, what we need to do is we have to add all the boundaries that we need. In this case, we have inlet, outlet, front and back, and ground. And when we check the three surfaces, we have buildings from the OBJ. And when we want to select all the boundaries, just select all boundaries here, and then all boundaries will be selected and add boundaries. Now we set the boundary condition for each and every boundary. For the inlet, P is a zero gradient and U is 10 meter per second, directing to the x positive, meaning from this boundary to that boundary. And for the turbulence, K is, we can also minimize this. Turbulence is 1.5, epsilon is 0.03, nu T is 0. For the outlet, for the flow, we set the pressure to fixed value 0, and then for the U is pressure inlet outlet velocity. Minimize the flow and turbulence, also inlet outlet. Same value for K and epsilon. Okay, we're done. And for the front and back, since the type is symmetry, VisualFOAM also automatically detects and set the boundaries for symmetry to be symmetry for all types. And then we go to ground. Same case here when the boundary is a type wall, the associated types will be adjusted automatically. For example, here P is zero gradient, U is no slip, and turbulence wall function set the same value 1.5, 0.03. Same case with buildings solid object 1.5, 0.03. Okay, we're done with the boundary condition, and for the next step is the numerics. So here the VisualFOAM workflow is streamlined from the mesh to physics configuration to numerical setup, and it all shows the step involved in OpenFOAM, in actual OpenFOAM, but in a visual way. So it should make us working with OpenFOAM much easier. Okay, for the numerical schemes, the diff scheme, we change it for the velocity from Gauss upwind first order to second order accurate, linear upwind select scheme. And yep, I think we're done for the numerics. And for the case control here, simple form, we can set to 400 for the end time. And then right interval is 100. So in total, we will have 4 data. And yes, that's all for the control dictionary. And for the parallel, just enable or disable it. For the mesh and solver, we want both are running in parallel, so we will choose or enable these options. Where the method is coach and the number of subdomains is 4. This is, you can adjust it as per your available resources. And now we are done, and just export case. Okay, we're done with setting up in VisualFOAM. Thank you.